Hey guys, this is Menak and today we will design a ground floor or a single story building in STAAD.Pro, and then we'll complete the design in RCDC, and then we'll also see the structural drawings of this. So this will be execution from the structural drawings to the site, or the practical execution. So the drawing part also will show you. So first of all, I have this particular drawing here. Let me just show you. So we have here a kitchen, here bedroom, and living area, toilet. So around 50 meters square. This built-up area is there in this ground floor. So this will be the mid landing, and if in future they want to just go for other floors, they also can do, but right now we're going to design this building only for the ground floor. So if you think of slabs, when you just see the column position, think of slab, there will be a secondary beam either here, we can do this, or either here. So I think we'll choose to do a secondary beam here or here. So like this you can do. So first of all is what we do is we do the coordinates. So if you just see the top view in STAAD, you can see in the x-axis in the STAAD, if you just look into the top view, is this one. Positive x-axis is this one. And if I can increase the text here size here to like 200, and then the positive z-axis is this one. So we'll do the coordinates accordingly to this. Okay, this is a positive x and positive z. Now first of all, by the way, all the study materials you can find in the description, so you can practice along with me. It's not just showing, it's practicing along with me, so that you can be ready for the site and ready to take up such works on your own, or if you want to get a company, take up such work. So my goal is that to make you capable and employable. Okay, so this is it, and you can see the center to center distance here, it's 2.55, 0. So it will be 2.55, 0. We are doing in meters because in STAAD we are always making the thing in meters. So if you can, I will just make this as a separate color just to be recognizable. Okay, 2.55, 0, and yeah, last one, and this one will be distance will be y calculate, just when you can just use the dimension here like this, it is 5.4. okay, so 5.4, 0. So bring the coordinates here, and you copy all these three, since all these three columns are in the next layer as well, next line you can call it. So here also it is there, and here also we'll find this, and here also we will find this. Okay, so yeah, this will be in here, this will be in here, and another one, this one will be in here, because will be doing a secondary beam from this to this. Okay, so this is a separate line. Now if you want to just know the coordinate of this, okay, we'll take from this to this, 3.4. so 3.4 is the distance for this particular. You can just remove this if you to avoid confusion. 3.4 is this one, so we'll write here, change this to 3.4, 0. That coordinate will change later, and this one also will change it to 3.4. okay, so this is done. Now once this is done, what we'll do, we will change the z coordinates. Okay, so here first of all this is done, and I'll just delete this remaining because I don't want to add, I just want to drag this. And so first is 2.586, first center distance is 2.586, so 2.586, this is the first distance. Just copy this and close, and yeah, this will be the same. So this is the same y level, 2.586, and this is this. Okay, and the next distance here which you have here is 5.475. So this distance is actually 5.475, Okay. Move it just to avoid this error. Just delete this things which you don't need. Okay, so this will be one coordinate which will be moved to, okay, we already have this. So this is 9.7, so just do this 9.7. This will be 9.7. Just copy this and paste it here, and here also paste this. Okay, so we have finished the coordinate marking here. So you can choose or not choose to give this secondary view here. So what I'm just choosing here, I'll just give this secondary beam, I'll ignore this one. Okay, this secondary beam I'll provide in the plinth level. In the next level maybe I'll not provide. Okay, so this from here to here I'll provide this secondary beam. Okay, first of all I'll just move in the coordinates because this is in the same line. X coordinate will be the same, only Y coordinate will change. So let me just pick the center line here. Okay, and in the center line just will take this a line here, and this distance I'll check the Z coordinate distance here. It will be 3.913, so you can just do 3.91. okay, just do 3.91. here also we'll do 3.91. so this is a secondary beam in this particular building. Okay, so now these are the coordinates. So let's just open Excel sheet and do the coordinates here. Okay, so just to open a new Excel sheet, new XLX document, and STAAD coordinates, and then open this. So let's go and input the data in the Excel sheet. So it helps us to just paste the data, and also it helps if you anyway lose the data, then it can, like if we have the stat, if you lose the stat file also, then also it helps to just do this. So X, Y and Z, and then serial number 1. Okay, first the coordinate will obviously be 0, and the Y coordinate instead represents the height. So the height, the plinth level will take as 0. Okay, so first of all let me just do this center alignment, and this, we can use any font of text here, but I'll just increase the text height here. Okay, little bit just to be visible here. Okay, I'll just increase more. I think let me go here 20. Okay, so yeah, this is it, and the next coordinates will insert one by one in the AutoCAD. Okay, next coordinates will be 2.55, 0. So skip the Y, 2.55, and this is 0. So next is 5.4, 0. Okay, 5.4, 0. So let's look at the next line. Next line is the same 3, but the Z coordinate is 2.586. So just write this first, 2.586, and copy this, more 2 tiles, and copy this and paste this. Okay, then we got to go to the next line. So the next line, I think this is for the secondary beams. So this will be 3.91, which is Z value 3.91, and I won't have to copy this to another point because there are 2 coordinates, and there are these 2 coordinates will paste it here. You can see 2.55, 5.4, and in the next the Z coordinate is 5.475. okay, so this is 5.475. good. And how many code points are there? 1, 2, 3 and then 4. Okay, 4 points are there, so just copy this and we'll paste it more 3 points, so total 4 points. And first point will obviously be 0, 2.50, and then the second point will be 2.55 will be there, and then 3.4 and 5.475 will be there. Okay, 0, 2.44, 2.55. First let's do this two, and then the third one is 3.4. okay, so this is the first time this coordinate is coming for the x, 3.4, and then after 3.4 is 5.4. okay, so this line is complete, this line of coordinates. And then the next line we have the same as the this we have 0, 9. Let's first write the y coordinate, which is 9.7, 9.7. We copy it 2 more times, and in the y coordinate first obviously we have 0, then we have 3.4 and 5.4. let us just double check, 3.4 and then 5.4. okay, and then we'll just copy this 0 and paste it here. okay, like this, and serial number also we'll drag this serial number, and this will be double click, you will have this serial number here. So the coordinates you have found out. So after that we'll open the STAAD.Pro. okay, so in the STAAD.Pro just click on new, and give your file location in here, select metric for SI units, and then just click on create. So after that what you need to do is you need to copy this, all of this like this, and once you copy this, and then you just click here and then paste this here and click on OK, and then you go to the top view here. okay, so once you go to the top view, you can just check the floor plan here whether this coordinates look similar or not. You can see if there are any mistakes. So it looks similar here. Overlap and just check. So go to geometry, and then first of all use the add beam command to add the beams here. This is a secondary beam right here. Just left click and then left click on that point. okay, so just click on escape here, and after clicking on escape we'll use the translation repeat to go below our footing depth. So you can see from the elevation part which is given here, just take a check here. So plinth level is 0.45, and if you go in this page you can see plinth level is 0.45 and then foundation level is 1.5. so total height is 1.95. if we add these two, since we are working on this level which is the plinth level, so total height is 1.95. okay, so we'll select all the points which have your primary beams. So first of all go to select the node cursor, and first of all select this node. And then since we are selecting multiple nodes, press Ctrl and then select this nodes, and then we'll select this node because this has column. We'll ignore this node because this doesn't have column, and we'll select these 4 nodes. These are for the staircase and it has columns, and then this node. So all the nodes which has the columns are being selected, and then we'll go to geometry and use the option of translation repeat. Translation repeat will be done in the y direction, since it's the direction of the height. And in the height we'll use the link steps option, and the spacing will obviously do minus 1.95. Why minus? Because it's going in the downward direction. And then click on OK, and then you go to view and you just select this model, and you see that the model has been prepared. So once this model has been prepared, we need to make this model to the next level. So to make this model to the next level, we just use this option. Just click on escape to escape from the cursor view to the node select view to the beam select view, or you can go to select and then select like this. Okay, I then first of all select this here, and then we have this particular thing selected, and you will use the option of translation repeat. We will not use your link steps in this step. We'll use the link steps one step after this. Okay, so y direction selected, so one step only. Now 3 meters is the height here. Okay, and then no link steps, and then click on OK. And after that, just you right click, since this particular floor is selected, right click and go to new view and click on OK. Okay, so only this view is now selected. So go to this top view and we'll go to select the node cursor, and we'll select the nodes which has the beams, sorry, primary columns. So select these 3 using control 1, this 4 and this 1. So once these nodes are selected which has the columns, so go ahead and go to geometry, go ahead and translation repeat, y direction 3 meter, and use the link steps command. Okay, click on OK, click on view, click on the 3D view here, and display whole structure like this. So you can some of you might assume, since we have just copied the node, it might have lead to some error. You can check this here, node tools, go to utilities, go to node tools and click on duplicate tools and click on OK. So no duplicate tools found. So this is the intended way to do it for dissimilar structures or structures having secondary beams, since always these structures have secondary beams, but in many tutorials you will not find this option. Okay, so this is a good option here. So in here this is the ground floor which has been created, but for safety purpose you can consider one more floor above this. Okay, just to be safe, extra safe, you can just to do one more floor. So for that, if select this and go to geometry and go to translation repeat, then this step will be done easily. But in this we are going to skip this step here. Okay, so this is our floor, and in this particular floor, okay, if you want to see this, press shift plus 2, just click here, shift plus 2, you'll see this particular view here. Right now you will not see because the properties have not been assigned. So after the properties we will come back to this. But if you click here and press shift plus 1, then you will see the front view. Okay, shift plus 2, you will see this particular view. Shift plus 3, you will see this particular view, which is the bottom view. Okay, so like this you can have some shortcuts here. Okay, so here and next we will go to properties. So let's define the properties here. Go to define. So our building in seismic zone 5. In seismic zone 5, the minimum range size for columns is 300 mm. You cannot give less than that. Okay, so 300 into 300, click on add, and then the next size which you're going to add is for our beams here. So for the plain beams we'll add here 250 into 350. We'll add this for the plain beams, and for the roof beams we'll add what size we had taken. We had taken here 425, right? So 250 into 425, and then click on enter. Okay, and then close this. Okay, so this is selected, and go to select and select parallel to Y, and then assign to selected beams, assign and yes, and select this 325. Click here, shift 1 to go to the front view, select this plain beam, and then assign to selected beams, assign and yes, select this and assign to selected beams, assign and yes. Okay, so here just go to view and display whole structure here. So if you want, go to utilities, go to node tools, and node to node distance you can check here from, like, click here and then click here. You will see this node to node distance. I can go to node tools, remove node to node distance. So node to node distance will be removed. So this has been assigned, and obviously you can also create some portion for the headroom also. So for that I'll just show you. Go here, go shift plus 1, and then simply you can select this particular view like this, and right click and click on new view, and then click on OK, and then we'll go to the view and this particular view here. So in here we can select, go to select and go to select the node cursor. So we'll select this node, or you can just go select the beam cursor, and in the beam cursor select these 4 beams and 4 beams, and use the option of go to geometry and use the option of translation repeat y direction, and the height which you have taken for the headroom or the mounting room or the room over the staircase, which is 2.4 meter, and use the link steps option. Click on OK. So once you have done this, we have to assign the properties for this also, this vertical portions also. Just go to view whole structure. You can see this has been already assigned since you have copied this, but this vertical one has been assigned. So select this 300 and then go to select parallel to Y and then assign. Okay, so view and display whole structure here. So this has been assigned. So after the properties have been assigned, it is important that you have one habit in your mind, just to check here. Go to select and property, and then you have this inactive member elements, failed beams. Okay, so missing property, go to missing property and go to missing property. Just check this, because sometimes this comes as an error if you forget to assign the property to a beam or a slab. So we are not assigning slab here. So go to materials. Now materials by default concrete is selected, so it's fine, no need to change anything. They have to do something in the specifications now. Now for the specification, now first of all, in the roof beam we'll delete this secondary beam part, because this secondary beam will not be required here since there is nothing above this. So we'll delete this particular secondary beam. This secondary beam will keep for later. First of all, let's create go to beam, and we'll create something for our supports here. So instead, all places where you have secondary beams, that is the beams which doesn't have columns, okay, so these are the secondary beams, we release the support. So in STAAD.Pro, the local axis, if you release this, this is the global axis, so we have also a global axis for the beams. If you release the support at that direction, that is enough. So we'll only release the support at that direction. If you release the support in other two directions, then it's also okay, it's not wrong, but only that direction is enough, since the local axis is which causes torsion is along that direction, so it is enough here. So click on just add here, and go to beam here again, go to end, and then MZ again, and click on add. So these two have been added, and again we'll go to the we'll go to the beam here, and in the beam we'll go property reduction factors. So as per our IS code, the property reduction factor should be, the moment of inertia for beams should be taken as 35%, and for the columns it should be taken as 70%. It is also referred as crack section properties. So you have to do this. So here this properties will be applied only in the lateral direction, is the X and the Z. So here first of all, let's add for the columns, which is 0.7, again 0.7, and again this will be 0.7. This is for the columns, and again beam, and this will be property reduction factor. So for the beam it will be 0.35, and also this one will be 0.35. okay, click on add, and then after the property reduction factor, we can add a master node here also. So but we'll add this later after this completing this. So go to select this and click Shift+1 to go to the front view. Select this, let's deal with this first. Okay, press new view and then click on OK. Okay, so we'll go to the top view now. So after going to the top view, here first of all select the beam which has which in both pinned on both sides, there is no column on this, no column on this. So we'll select this and assign, and yes, and N2 also will assign, and yes. So this has been assigned, and for this you have to know which one is N1 and which one is N2. So in this end there is no column, and this end there is column. So you have to know which if we have to pin at this end. So now how to know whether this end is starting or end? Just hover your mouse over this, okay, and if this just I'll zoom in to let you know. I'm not selected or anything, just move your mouse over this, or click and hold, click the left click and hold, don't do anything. You can see the green portion is the start and the blue portion is the end. Or you can also use the right click and go to levels and then turn on this beam ends, and then also you will find this, okay, every end you will find. So right now it's not required, okay, apply and okay. I know that I just since this is only one, I know this is the starting which I have to pin. So select this and start, and then assign this, okay. So this I have to pin, so this I have done. So the pin for this particular portion is done, and then we'll go to the next. So go to display whole structure, go to the front view and we'll select this particular portion, right click, new view, click on OK, go to the top view, and in here there is only one secondary beam, and you know this is at the start. Okay, start, and assign to selected beams, assign yes. Okay, like this has been assigned. Now let's apply the property direction factors, display whole structure here, and property direction factor, this one is for the columns here, and go to select parallel to Y and assign and yes, and property direction factor for the beams here, and select parallel to X and parallel to Z here, click on assign and yes. Okay, so let me show you the code here for this property direction factor, because otherwise some people might question you where you found if you cannot find this code by yourself. So open IS 1893 part 1 2016, just type in the PDF page number 16. So you'll have this in RC masonry structures, RC, and there is a reinforced concrete and masonry structure. 70% Y gross of column should be taken and 35% Y gross of beam shall be taken as the moment of inertia. So you find this is the definition for the crack section or for the beams here. Okay, beams and columns. Okay, brother. So this you have found. Now we'll assign the master slave. So for assigning the master slave, so go to view, and we can also assign the diaphragms also, but I just master slave is a lot simpler, so I'm just assigning this for now. Right click and click on new view and click on OK, and then we'll this is done. So we'll go to node, and you have this two options. Flow diaphragm is the better option, but in this video we're going to go with the master slave here. Okay, so rigid obviously, and you need to just define the master node. So there are many nodes, so you need to define the master nodes. So you need to find the center here. Okay, so for normal structures approximately also you can find the center node and assign it as the master node also. So there is no problem in this particular building. So this is approximately the center of this particular building, so we can assign this node as the master node. So to node shift N to find the numbers of these nodes. So if you just shift N, you can see the node number is your 10. So we'll assign this node 10 as the master node here. So master node is node number 10 here, and click on this add button. Okay, master node 10, and for this master node 10, all the other nodes, slave nodes which I'll assign, should be in the same level. Okay, so select this like this, or you can just also go in the select cursor and the node cursor and select this like this, and they should stay assigned to selected nodes, assign and yes. Okay, so this master slave is assigned for this level. So go to view and go to display whole structure, and go to the front view and escape and select this particular portion, new view, click on OK, and go to the top view here, and this node number shift N, select this and then shift N. This node number is 37, this node number, so shift N again, and now we'll assign, go to nodes, and here node number, this will be node number 37. Okay, 37. Okay, click on add. So node number 37, and this node number 37 is master node. So go to select node cursor and select this and assign to selected nodes, assign. Okay, so this is assigned here, and go to view and display whole structure, again select and go to the front view and escape. Now this particular thing is remaining, click on new view and click on OK. So let's go into top view here. So in here, that there is if you don't apply also, then it is also okay, because there is literally the center will be in this particular portion, so diaphragm approach will be better here, but let's skip this one. Okay, for now. So display whole structure and the master slave node have been assigned, and if you have pressed shift L, you can see the node position. So you can see it is almost at the center here, master slave position. Okay, so you can see this. So this master slave node has been applied here, and then we'll go to supports, create a fixed supports. The fixed supports denote the connection between the monolithic connection between the footing and the column, which is here. So this connection it is represented by the fixed support, so that the moment and forces are transferred properly. Okay, so just click on fixed and select this shift +1 and select this nodes and assign to selected nodes, assign and yes. You can just go to view and check out your fixed supports in the description. And here after this, then we go to the, you can see I have starting from here, I have just not skipped any step, serial by I have gone like this. So if you do like this as a beginner also, and when I also started as a beginner, I also started from here. I also consider myself beginner now, that's another thing, but you know, starting from here and end to up to this much. Okay, so since this building is in seismic zone 5, so the wind load will not be dominant anyway, so the seismic zone load will dominate. So we'll apply only the seismic load and click on add here. So the zone definitions and all we'll do here. So first of all, select your code. We have the latest code in this version of the Connect series, which is the 2016 here, and we'll click on generate here, and this will be zone, and this will be our zone is zone 5, and we'll use RC buildings with special moment resisting frame. This option you'll find in number 2. So as per the IS code, this value response reaction factor will be taken as 5 here. So which you can also see here, you can see the response reduction factor is 5 here for RC frames with special moment resisting buildings as per table number 9. Okay, and then you find the soil type. Just as per the soil test report, you have to give this. So this table is also in table number 1 or table number 2 in the IS code. Okay, and then damping ratio is always 5%. Foundation depth in our case is 1.5 meter. This is also you'll find the soil test report. Period in X and period in Y. Just calculate and put it. Okay, just calculate and put it. Okay, it's better to calculate and put this in the software, because sometimes you know this leads to error. So we are following this clause, that is a 1893 part 1 clause 7.6.2 for all other buildings. Some people do for buildings with without masonry infills, but if you have masonry infill simply means brick walls. So you have brick walls here, so we follow this particular option of all other buildings. So first of all, you can see what are the factors required for this time period. 0.09 is constant. Height of the building we need. So for the height of the building is 3 meter plus 0.45. So height of the building is taken along with the plinth level, plinth height. Okay, from the ground level the height of the building is measured. So 3.45 meter, and in X direction and Y direction. So first of all, I'll do this as 3.45 instead of 6.45. Okay, and then the direction in the X and the Z. Okay, we'll just measure. Already we have X and the Z distance in here. Okay, we have this. So you can see in the X direction the center is the 5.4. So approximately this is enough. 5.4 in the X direction. Okay, and the Z direction we have this 9.7 in the Z direction. So this should be calculated here. So let me just calculate this and put the values in here. So these are the values which have come after the calculation, 0.13 and 0.1. So let's simply put the value 0.13, and this will be 0.1, and click on generate. So in here you have this particular values. Click on add. So the seismic weight and other things will add later in here, and so simply we'll go to the load case details and define the particular loads here. So let's go forward and put the load case here. Click on add. So here first of all we'll add the seismic loads, because always you need to add the seismic loads here. So we'll add the seismic loads here, seismic, so SLX, and if your building is in seismic zone, SLX, and then seismic, this will be SLY, YSLY, I'll just tell you, and then the SLZ. So if your building is in seismic zone 4 or 5, then you need to add the loads, consider the earthquake loads in the vertical direction as well. Just come to the code to just tell you that, because you might not have seen this earlier. Well, so all these have been added, and then I'll just show you the code here. So go to the code and type 11 here, and here you'll find design vertical earthquake effect. So if the structure is located in seismic zone 4 and 5, you have to consider the vertical effect of the earthquake also, and the structure has planned irregularities based on soft soil, bridges. The structure is long span, that is 7 meter, 8 meter, 9 meter, 10 meter. Structure is large horizontal lower angle, that is large cantilever something. So you have to consider this, and also the load combinations are also different here. So if you do design by the automatic load combination with the software generated, then also you will not be enough. Okay, so how to deal with that? I'll give you an option in this particular video, so no worries in that. Okay, so let's move ahead with this. So first of all, I'll add this seismic load X, and this will be seismic loads in the extraction factor 1, right? And the remaining things I'll add in the STAAD editor for the seismic, for the command file. Sorry, earlier it was called STAAD editor, now it is called the command file. So here just copy this and add, instead of X just do Y, capital Y. Turn the caps lock on now because I require this, and this, instead of this it will be Z. Okay, now let's go and ahead and apply the dead load and all. Okay, go to loading here. You can see this is have been applied here. Okay, go to it and let's complete the dead load part. First of all, self weight -1 in the Y direction, and then the member load here. So we have 125 mm wall here. So 125 mm wall, 0.125 into 20 unit weight into 3 meter, which is the height, 7.5. So -7.5 will be added on all the spans here, and click on add. And then for the parapet wall, we'll add, let's say 0.125 into 0.1 into 20. So it will be 0.125 into, let's take the 10 inch 250 mm walls for the parapet wall for extra safety, into 20 into just 0.25 into 20 into 1. So let's take 5 for the parapet walls here. Okay, -5 for the parapet walls. Okay, close this and click on dead load, also floor finish load. Okay, floor finish load, since we have only one level, is the plinth level. In plinth level, you don't want the floor finish load, don't need. And in the roof level, we'll have the floor finish load of 1 and waterproofing load of 1. And also we need to add the slab load, because since you have not applied any slabs here, so slab load, consider 125 mm slabs here. So 0.125 into 25, which is the unit weight of concrete, and it will be 3.125. So 3.125 plus 2, it will be 5.125 along with the floor finish and this. Okay, so let's do here -5.5, and it will be applied in groups here. So let us first assign the group, but this value will remember -5.5, which will apply here. Okay, so for the grouping, let's go in the ground floor. There will be no grouping here, only at the first floor there will be grouping. For the terrace level there will be grouping, since ground floor will not apply any loads, floor finish loads, or loads, live loads. So okay, so select this and right click and click on new view, and then click on OK. So, and load the top view here, and now you can see which portions are the one way and which are the two-way slab. So all these are two-way slabs here. So select this like this and select this like this, and this portion doesn't have any slabs. So okay, so press Ctrl+G and make this as, first of all, floor, and group name, this group name, make this group name as terrace, and then two-way. Okay, terrace two-way. Okay, floor load and click on OK, and assign to selected geometry, associate to selected geometry, associate. Okay, and you can highlight to just check this, select this and then highlight, just check this. Okay, now we have one more portion remaining, which is the headroom portion. So display whole structure, go to front view and select this headroom, right click and click on new view and click on OK. So here in this headroom portion, we'll just select this. This is obviously not obviously, let's just check here, node cursor, or you go to utilities, just you can see from this portion also, this distances you can check here. This is 2000 and this portion is 4225. So this is a little bit more than 2, so it is a one-way slab. Okay, so this is a one-way slab. So this portion, select this and Ctrl+G, and this will be our associate to selected geometry associate. Oh no, we have messed up. This is not this should not be done. Okay, first of all let's create, we'll just correct this. And this will be floor, and this is headroom, all in caps, headroom, no space, don't use any space here, headroom, one way. Okay, and associate selected geometry associate. Okay, and then use the highlight option to check. Okay, highlight to check. Okay, and then this also I think we have messed up. They are not, let us check here. So first of all, go to view, go to display whole structure, and then highlight this. Okay, this is okay. This is also okay. So headroom one way and terrace way to floor, this we have added. Now go to dead load now and add the floor load here. What was the value? It is around 5.5, so minus 5.5, obviously in the group here. Now this will be applied in two groups here. First of all, there is two-way, so no one-way distribution click required, and then click on add, and then this will be terrace headroom one way, so one-way distribution is required. Now click on add and then close. Okay, so these two will be automatically assigned since we have defined in the groups, automatically assigned. You see the load distribution for defined for one way and two way, that's why this grouping is required. And this because this, you can see the arrangement is different for two way and the arrangement is different for one way. Okay, so select this and assign to view, and the 7.5 load will be, go to front view here, select this, and then assign to selected beams, signed and yes. And then in this portion, right click and then click on new view, click on OK, and then go to the top view here, and in this portion in the headroom portion we'll apply the assign to selected beams, assigned and yes. And this one is for the select beams, assigned and yes. Okay, so this is done. And for the live load, utilities and command file, and in this utilities command file, just select this load here. You will only change the value, the magnitude will be the same. So this will be 2 for the residential buildings live load. You can find in live load code 875 part 2 table number 1. Okay, so you can find this here in that particular portion in here. So live load has been defined. So now we'll define the your seismic weight. So what is the seismic weight? The full dead load plus the percentage of the live load. What percentage of live load is taken? So if our live load, I'll just open it first and then show you. So you'll find in in the code or 93 table number 10 this particular thing, percentage of the imposed load to be considered in the seismic weight. It should be 25 percent if it is up to 3, and 30% if it is 50%, if it is more than 3, 50%. So here it is less than 3, which is 2, so 25% will be considered, which is 0.5. 25% of 2 is 0.5. So first of all the dead load here just copy, including the self weight, right? Just copy this here. Okay, so this is copied, nice and good. Below the seismic definition, paste it. Now to convert this into seismic weight, get rid of this sign and get rid of this direction, and in this member load just do this as member weight, WEIGHT weight. Good enough. And then this, get rid of the direction and get rid of sign. UNI, keep this. UNI means uniformly distributed load, or UDL kind of, you can assume. So UDL should be kept. Now in this floor loads, there are two types of load. So if this is floor load and this is the two-way load, then you make this as weight, WEIGHT weight, and then obviously get rid of the sign and get rid of the direction. But if this is a one-way load, here many people do mistake. If this is a one-way load, then what you have to do, then you have to keep this as one-way load only, and here you have to do this GX, and you have to do this as, remove this negative sign. Okay, now in the one-way in the two-way load, we'll add the another load here for the live load, portion of the live load here. And similarly we'll do in the one way load also. So live load portion will be 0.5 here, and live load portion in this also will be 0.5. okay. And once you have done this, go to escape and do the check syntax to check if there is any warning here, and then you can close this. So if your program is wrong, it will not open and show some errors. So, okay, so go to loading here and go to definitions. First of all, you can see all the definitions here have come: self weight, member weight, and then the floor weight, and then the one way load. So everything you can find it here, and you just close this. And the live load also you have done in through this live load also, you'll find this live load here. Okay, so here you can find like this. So obviously we'll have the load combinations and all, but let us first of all do some other things and just check this. Okay, go to analysis and go to analysis commands. You can just click on add all and click on add and then close, and then run analysis just to check whether you have any warnings here or errors, warnings which you can definitely fix. So we have one warning here, so let's see what is the warning here. So this is the warning which you want to solve, which is this UBC analysis has tension or compression. So we need to solve this warning. Okay, so just go here to this command file, and then from here you can find here perform analysis command. Just copy this. Okay, copied, nice and good. And in below this you write this perform analysis and then write change. Okay, you have this here, and copy and then paste it here and then paste it here. So all the seismic loads, we have this command done, and then close this. Analysis and design, run analysis, 0 warnings. Okay, perfect. So we don't have any warnings now. Now what we can do, we can go to design and we can perform some design parameters as well. Okay, so obviously concrete IS4 456, just select concrete, then automatically IS4 456 should come. If this is not coming, then go to the settings and change your default settings to your country code, then it will be coming here. So once this is done, then you can, or if it is not coming for now, you can just select this from your drop down menu also. Don't stress too much. Okay, so first of all I'll define two parameters, select two parameters here, so which is FC, FI main and FI secondary. Okay, and then click on OK. Remaining parameters is not required right now. FC is M25 will take 25 after that at 3 zeros since it's kilonewton per meter square, and FI main will take FE 550 550 1 2 3. Click on add, and FI secondary 550 1 2 3. Click on add, then close this, and you will find this here. Okay, so simply assign to view, done. Now go to commands, design beam, design column, takeoff you don't want. This the takeoff will give you the quantity of concrete and all. If you want, you can add and assign to view. Okay, so this will be parallel to X and parallel to Z, and then these are the beams assigned, and yes, select the column and parallel to Y obviously, and assign to selected beams assigned, and yes. So once this is done, go to analysis and design and run the analysis. So if you have any errors in this process also, we'll fix those errors, and after that we'll add the load combinations also. So two warnings are there, so let's see what are the two warnings here. So yeah, depth to ratio of is member is this one is line number, and this is the member number. Okay, so what we need to do is, in this warning we need to see the member number. So you can see this member number here. So just open a notes file. So 7 is member 7, so just like 7 here, comma, and then you select this one is 40, so just write here 4040. okay, so we have noted down these two particular commands here. Now we'll just close this and we'll just go to define parameters. We don't have any other additional parameters, so we'll go to select parameters. So in the select parameters, so we'll add a new parameter here, so which is the ENSH. You can see perform shear check against enhanced shear strength. Okay, so this parameter you can find from here, ENSH. okay, so and after you find this parameter, just put it here and then click on OK. So here go down and define parameters here, ENSH, and this value do this as 1. okay, and then click on add. So once this you click this on add, you can find this in here. So ENSH here, and you will assign to edit list. okay, in the edit list you have this thing done. Copy this and paste this and click on assign. And since you can see some small column beams, this error comes assign, and this has been assigned, but you have to do another thing. Go to command file, save this obviously, and you have to move this function before the perform analysis command. okay, so you have to find the ENSH command here. So here you can see perform analysis fc main ENSH. You can see this one. okay, so in this particular command you have to control plus X and close this. So it will be before the design beam command, you have to put this. okay, not the perform analysis, design beam command, you have to put this. So ENSH member 7 and member 40, control plus S and then close. So after that, go to analysis and design, run analysis, and then check. Now there is 0 warning. okay, 0 warnings. okay, so now you can check the design. It will be pretty much good here, 412, and because we have not applied the load combination here, right? Beam design, you can see 3 bars of 10 mm in the top and bottom, and this also 3 bars of 10, 3 bars of 10, and the other columns also. You find the design here, 4 bars of 12. We have not applied the design combination. The things are coming pretty much very much economical, but we need to add the load combinations. So to add the load combinations, I'll give you a trick, because all the load combinations should be as per the IS code. So I'll give you this file here. So for this file to act, this should be in the exact same order, X, Y, Z, and then dead load and then live load. Then only this thing will occur. Just you can see this, copy the service load combinations from here. okay, and also the strength load combinations here. These are all as per the IS code. It will save lots and lots of time actually. And just copy this up to this much, control plus C, and go to the command file in your STAAD. And after you go to the command file, control, and you will scroll to zoom in, and after you have defined the loads, okay, and before the print all command, just paste this. okay, paste this, and after this thing also, perform analysis also, you can press the define envelope also. That is also a very interesting feature. When you define some envelopes, you actually just have pretty much good control over the post analysis part also. So I'm giving you the shortcuts here so that all of you guys can save your time and perform your task effectively. That's my only goal. Okay, not only goal, one of my goals. okay, so define envelope, and define envelope is and then we have to start concrete command. Let's press Ctrl plus S and then close this part, and then let's go analysis and run analysis here. So let's see if we have any warnings. Now we might have some warnings. Okay, no warnings. Okay, fine, that's absolutely fine. See the concrete design, 4 bars of 16, so it is pretty much givable. It's not that much, 4 bars of 12, so properly done. And the design is also not that bad. okay, so design is also proper, 4 bars of 12, 4 bars of 12, so properly done design. And then we have this So, and then obviously these are the remaining steps in the RCDC part, which we'll do, and we'll go up to this complete execution for the structural drawings here. Okay, let's just have a look in the loading part here. You can see this is the load combinations which I've added. You can see these are the envelopes which have been added here. So what are the use of these envelopes? Before jumping into RCDC part, let me just show you this. So go to the processing mode, and you have this envelope 1, which is the normal envelope. You have this unfactored load combination, which also can be used for the footing design and all, and you have this envelope 2. So if you click on apply and click on OK, and in STAAD always local movement is along the Z direction, so you'll see movements in Z direction. If you want to magnify it, control and press plus will magnify this, and shear force you'll find in the Y direction. You can find the shear force here. Okay, you turn off the displacement, you will find the deflection also here, control, and you can see the deflection also here, and you can find the utilization ratio here also. So beam stresses also, you can just find out the beam stresses also. And if you want annotation at any point, suppose if you want the moment, you want the annotation here, moments for the annotations, you can turn on the annotation, but this will be very complex here. So just I'll select a particular beam here and right click and then click on new view and click on OK. So moment is done, and just increase the magnitude here, control and your mouse cursor. You can see moments here. You can just go, not the animation, we don't want the animation, just go to the annotation part, annotate, and then here beam results, bending, and maximum midpoint, turn this all, annotate, and then close. You can see these are the values, maximum value, minimum value, like this. You can find this out. So you can find the bending moment and shear force also. So shear force also, let's go and simply go to annotate here, beam results, and shear force results also, annotate and close. You see these are the maximum shear forces here. Okay, remove all and close. Okay, so like this you can find the shear force and bending moment here. Okay, save this file obviously, and after saving this file we'll go in RCDC, because the final goal in here in this particular tutorial which you are doing along with me, I believe, is to give the final drawings for the site. Okay, and I'll anyways provide you with all the materials which is required for that, at least starting your work, and later you can modify on your particular style, design type and all. Okay, give all your details here. Okay, I encourage this, skipping this step for now. First of all, I'll design the columns here, create new project. So first of all, for the column data, go to level data and change this. Okay, in this case I'll use 550 and cover will be 40, and I'll just copy this from here, Ctrl plus C, and then paste it here, Ctrl plus V, and then I'll go to settings here, design settings, and if you want ductile detail, just click here. But since this is a one-story building, I don't want the building to be too much. Now I'm just going to practical way. Ideally you should give, but no, I don't want too much thing for too much heavy reinforcement coming. So I'm just skipping this step since I've already applied all the things in the STAAD.Pro. So click on OK. But if you want extra safety, just click on ductile design. Okay, so go to settings and basic load cases, and here I'll define the load cases here, seismic load X and seismic load Z here, and then the seismic load Y, and then the dead load, and then the live load. So by the way, I'm going by equivalent static method. Okay, if you go with response spectrum, the structure will be a little bit heavier, which we'll do in the later videos. Okay, also the response spectrum part, and you will add from analysis, because these load combinations even the RCDC doesn't have. Okay, so we'll go by OK, and then we'll just click simply design. So we followed all the criteria, and you can see this. If we not just ticked on the ductile detailing, that's why it is coming. If we just tick on ductile detailing, the results will be different here. So it is passing in 412. But if you go to just unlock the design here and just showing you how much different ductile detailing brings here, design settings, and turn on the ductile detailing part, and then if you design, then you can see the difference here. So even one beam is failing here, and 425 and 420 this is coming. So for in most important buildings you can go for this ductile detailing part. Okay, or even you can but for this particular thing I'm just ignoring this ductile detailing, since in single story building if I give that much reinforcement that will not be fair and not be possible. So that's why I'm using this. Okay, so here, or you can use this, or you can use the results in the STAAD itself, okay, which you are getting. You can use those results as well. So it's okay. So you can save this file, and also since you have the same design, not required to save, just go to schedule and save the schedule here, and you can also save the project schedule here. So I'll need the design calculations here, design calculation part here. So I'll just save the design calculation for any column. If I save, it is enough. You can see all columns here. So I'll save this as my Control plus P, Microsoft into PDF, and I'll save this as my this is my project 7, and this is my column design calculations. It's required this for my project, and that's why I've saved this, and I'll go to file here and go footing design. Okay, save. Now save this project, press Ctrl plus S, project will be saved. So footing design can be done in a single go, because we don't need to change do the other settings as well. So that is a good one. I shouldn't have cut it actually. Okay, I'll just cut it now, and then we'll go back to the footing design. Go back to the file here, and then we'll just see the footing design. Shouldn't have cut the file, I should have thought. Okay, so let's just go back. Go to the column, open the column RCDC file. So here I'll go to file and go to create footing design, and then click on don't close this file, this is loading, so that's the mistake I did. Okay, and click on accept. And then we go to this you can, before clicking this, just go to settings here and general settings, and set the SBC as per the soil test report. So I'll going with 170 SBC here, and then click on OK, and then just click this, and this I already have added from analysis here, because it has taken the values from the column design part, and this will just add from template for regular structure. The sizing, this is the unfactored load combination, so this can be added from analysis. Click on OK, and then you just have the footing design here, which is ready here. So for the footing design, we can just save the project here. So we'll go and first of all go to reports, and we'll go to the, you can just save the schedule here, which is set in AutoCAD file. You can take the detailed drawing and go to the design summary, but for me I'll only need a design calculation for any particular footing. Let's take this FC12 here, and then we'll just go and design, see this design report, save this design. First of all, save the file here, and this will be footing. RCDC file is saved, and then also the design calculation. So then the government projects, you need to submit the design calculation report, so that's why I'm collecting this, footing design calculations. Save this, and now once this is done, then I can close this, because now for the beam everything will be separate. This column and this synchronization is not present, so you have to go again here and go again to the advanced concrete design. Okay, analysis and design, just run the analysis once again. Sometimes you have to do that. Okay, done. And after that, go to advanced concrete design, Let's go for the plane beam first. 0 plane beam, create new project. So in here, first of all, you go to settings, general settings here, and go do this as FE550 M25. It's okay. Ductile design, if you want, you can click, or otherwise you can ignore this. I'll also show you the difference here. And if you just click on the ductile design, click on OK here, and then click this, and obviously you'll have the load combination, seismic load. So you can go by this design, and if you just click on ductile detailing, let's see what is the difference here. So if you might question now, have a question in the comments, so that's why I'm telling you. So if you want to take the results from STAAD, you can take directly after applying the load combination, not required. If you want to take the results from RCDC, safe it is to go for ductile detailing. Okay. But if you, in this case, this particular case, it's only a ground floor building, and don't want to just over give things here, so that's why I'm not taking. But yeah, I think for the beam, ductile detailing is quite fine here. Only one member have failed, 312, 312, 312. This is perfectly fine. Only one member has failed. So if I just increase the size of one member, I can go with ductile detailing here. I think we could go with 400. So this is seismic zone 5, and we applied all the loads, so that's why it is coming a little bit much. I don't know whether we can be able to solve this or not. Okay, we'll go higher size. Yes. So it's better if we just solve this particular beam by STAAD.Pro also. Okay, so 315,600, so it is going like this. So we'll accept this now. So you can go by ductile detailing if you want to just give this particular design here. So we can take the design report here, modify and reports, and go to text schedule and design summary, and you find all these things. I only want the design calculation, so I'll go B1, B2 design calculation. Okay, and then we'll just save this particular RCDC file first, and then you can press Ctrl+P and then save this, print this, and this will be the plinth beam design calculation. Save this one, and we'll just see which one beam which has come that much result here. Input, you'll see this particular beam, this has come, and this particular span, this has come 600. Okay, so for now we'll just close this, and we'll get to our STAAD file now. Again, obviously it will open here, and we'll just do analysis and design, run the analysis once again. Now this time we'll go for the loop beams. So here using your RCDC, I'm telling you again and again, you can just go directly for the STAAD results here, so that is also fine. We are going for the RCDC because in large projects, one by one might not be possible, so that's why we're going. But if you are comfortable with the STAAD results itself, it's perfectly fine to use STAAD only. Okay, no need to just go to this RCDC portion. You can go to the RCDC portion for the footing, I guess, and for the remaining things you can. So we'll go 3 here, create new project. That is the terrace beam. So here go to settings here, and just change this to FE550. Click on OK. We'll go and define this seismic X, seismic Y, seismic Z, dead load, live load. Select this, go here, add from analysis. Okay, and then let's design first, and then we'll see the difference which so you can see this is the design. So unlock this design now. All 310 is coming, everything is passing. So we now turn on the ductile design. Okay, and then design. Let's see if everything passes or some fail occurs, something occurs. So you can see one beam has failed. That obviously that particular beam we have to change and make it pass. So but remaining everything is passed. Okay, right click and then design this particular beam. So I think it was 300 into 600 earlier. So let's try this in this portion as well. 600, and let's try design. So it's passing except this. Okay, and then press Ctrl plus S, and then you can just take the reports and all, and just on the design calculation for a particular beam. So V1, V2 I want, and click on OK. So here I'll just press Ctrl plus P to take the report here, and it will be my roof beam design calculation. Roof beam design calculation. Click on OK, and then close this. So now as per your design results, whether you do it by RCDC or you do it in STAAD. First of all, you need to place your plot like this, and you need to just give the what are the names of the other owners of the plot. And this is a side plan actually. If you preferably you can give a water groundwater recharge portion also, and otherwise the road is the plot in here. So this area statement you can give, which you'll find here, and then you can obviously give this floor plan along with this table, which you'll find. You can make this, and then you can prepare the elevation and section here for the particular building. So your aim is to give all the things which are required. Then you can give a section for the septic tank, and then this is the details for the rainwater harvesting, and then you have the column layout which you can give here, whatever the column layout. It was coming 412 without ductile detailing, so if you give a little bit extra also, it's fine. 616 you can give here, and then the footing size also you can see a little bit larger also you can give footing size, because you don't have the soil test report, then it's fine. You give a little bit larger size also, then it's also fine. So you can give the footing reinforcement. Then you have this particular section showing the footing reinforcement. So you can modify this particular format according to your will, but I'm just giving you this format for free, so that you can start working, because I want to start working and then keep learning. And then if you learn something which I don't know or which I'm doing wrong, please let me know in the comment section, and I'll be happy, because most of the things I've learned from the starting making these tutorials, I've learned from you guys. So I'm very much open to learning and improving and also making you guys better, along with getting better myself. So you can have this plain beam diagram here. So you have this near the supports and at the center. Since for the beams we have the extra bars near the supports, so that's why it will be near the supports and center, and at the bottom we have the extra bars at the center. So for this also you can see this diagram at the end also, zone 1, zone 2 and extra bottom. So this will also give you this is also in the S code, in the ductile detailing code, this one. And this is for the staircase, typical staircase plan, and this is for the slab you can design by Excel sheet. Available many Excel sheet you can purchase, very small amount you can purchase if you have on the good Excel sheet, 300 400 500 rupees, and then you can just insert the length and breadth, and just insert the loads, live loads and dead loads, and then you can find the slab design and provide the slab design like this. So it's pretty simple here. Just start doing the design and you learn the things in the way, and hope you can design this building and also the other buildings and projects which you will receive as a civil engineer, structural engineer. Okay, so that's all for today, and hope you guys have learned something new from this video. Thank you, bye bye, stay well.